A water trough is 10-meter long and a cross section has the shape of isosceles triangle that is 1 meter across the top. Okay, the trough. So generally the water trough. So this is a water trough. So suppose if we connect another one, it may look like this. Okay, yeah, like this. And he's saying that a cross section has the shape of isosceles triangle. So this cross section will be isosceles triangle. Okay, will be isosceles triangle. So it is nothing but a prism, a triangular prism. Yeah. So it is 10-meter long. So the length of the water trough is 10-meter long and has a shape of a isosceles triangle that is 1 meter across the top. So 1 meter across the top. Okay, this the top breadth is 1 meter and is 50 centimeter high. The height of the trough is 50 centimeter high. 50 centimeter high. 50 centimeter high. Right. Next, the trough is being filled with water at the rate of zero point 0.4 meter cube per minute. Okay. So the rate, see, it is actually meter cube means volume. It is related to volume. So dy by dt is equal to zero point 0.4 meter cube. Okay, and how fast will the water level rise when the water is 40 centimeter deep? Okay, so initially the water is at 40 centimeter deep, it seems. So the water is at this level. Okay, 40 centimeter deep. Okay, so from here onwards, the height will increase, right? The height will change. Like when I am filling the water level will rise, and it will come up to the brim, right? So here, when the height is changing, even the width also changing, right? So here the width is different, here the width is different, here the width is different. Okay, but when it comes to the top, then it will be 1 meter, right? So you take this situation, you take this triangle. Okay, so this triangle and earlier triangle when it is at 40 centimeter height. So yeah, and the full height. So this 1 meter is taken as 100 centimeters. Take it as 100 centimeter, and this is 50 centimeters. This height. Okay. So now it is going to change, right? After some time. See, initially it is 40 centimeter, but it is going to change, right? So now we take one situation here. This situation we will take. Okay. So at this situation, the width W, that 100 centimeter. So it is changing now. I'm taking it as W. It's a variable, and this one is also getting changed, right? You take it as H, height. Okay, this is changing and this is changing. Height is changing at the same time. Width is changing. Okay, so make it this as 100 centimeter and this is 50. Now these two triangles are looking like similar triangles, right? Yeah, they are similar triangles. So now you take this triangle, and in this triangle this is the 100 centimeter width and this is the height. Now you observe this one, the small triangle. Okay, so this is the width and this is the height. So there are corresponding sides and corresponding heights. Okay, so the corresponding sides are in the same ratio. At the same time, corresponding heights are also in the same ratio in the similar triangles. These two are similar triangles, right? So that ratio will be equal. So 100 divided by W, 100 divided by W is equal to 50 divided by H. 51 times 50, 2 times. So 2H is equal to W. W is equal to 2H. Okay, fine. Now we need to find the volume of this prism. So generally prism you just assume like this. So the okay, so here the triangle is raised up. The triangle, I'm keeping triangle on triangle, triangle on triangle, triangle on triangle, right? So that means suppose initially triangle will have its area. So I'm keeping area on area, area on area, area on area. So area is increasing itself, right? So that means area of the base into, so many triangles we are keeping, right? So it gives the height. So area of the base into height is the volume. Okay, yeah. So what is volume of the prism? Volume is equal to area of the base into height. So here height is uh, this one. So this is nothing but length of the trough. So you take it as capital L. Okay, and area of the base. Base area will be area of this triangle. Okay, base. This is the base. Triangle is the base. So half into base into height. Okay, so W. Now half into base. We are taking base as W. W and height. Height is H only. Okay, into L. L is already given. That is 10-meter long, right? So write it as 10 meters. This here it is given 10-meter long. Okay, next, and this V. Right. So even W. So we got W value now, that is 2H. So write 2H there. So V is equal to half into 2H into H into 10. So we are not taking the width as 100 centimeter, or height is like 50. We are not taking because they are changing, right? These are only at one situation, but it is changing according to the situation, na? Right? And initially the water level is at 40 centimeter height, but height is also changing, right? According to the height, W is also changing. That's why that area of the triangle is only changing. That's why we are taking in the form of variables only. Okay, and moreover they have a relation. W and H is having a relation, relation is related to the similar triangles. So in similar triangles, the corresponding sides and corresponding heights are in the same ratio. So yeah, we got like this: 100 by W is equal to 50 by H. So W equal to 2H we got, right? I substituted here. So 2 get cancelled. Now V is equal to 10H square. Now differentiate. Do differentiation on both sides. Differentiation on both sides. So V is equal to 10H square is there now. I'm differentiating on both sides. Okay. So dv by dt is equal to differentiation of 10H square. So 10 is constant, it comes outside, and d by dt of H square. Okay, and 10 into H square, differentiation of H square, it is 2H power 1 into dH by dt. Okay, so dv by dt. Yeah. So dv by dt we already know that is zero point 0.5. The changing volume, zero point 0.4 volume, and 10 into 2 into height. Height is also getting like a height, initial height. This is height, initial height we have to take. So initial height will be how much? That is 40 centimeter, right? 40 centimeter is converted to meters. Okay, 0 0.5, and this is dh by dt. So 0.4, 0.4 on both sides get cancelled. Next, so 1 by 20 is equal to dh by dt. Okay, actually this is in meters. Okay, so dh by dt is equal to 1 by 20 meters. So convert into centimeters. 100 centimeters divided by 20. 20 ones are 20. 5. That means 5 centimeter. 5 centimeter per minute is the answer. Per minute.